about here? Who's going to be here?
Go for it. You're good.
Yeah, let's go. So I'm James. I am one of the team leads for Team 1466.
I'm Eric. I'm another one of the team leads. Or
You're a
sub-team lead.
Yeah, control team lead.
Yeah, you said it.
And so let's get into it. So we will have questions at the very end. So if you have a question at any time, please feel free to raise your hand, and I will try to answer it. So here we're going to outline what we're going to talk through. We're going to talk about wiring, tools, connectors, wiring, powering the robot, CAN, and then troubleshooting common issues, and how to learn more about wiring. So starting off, reliable wiring is one of the most important things you can do for your robot. Obviously, if you're running this robot for a lot of time, you want it to run consistently. If there's inconsistent wiring, the robot's not going to run, which is potentially not the best, right? Electrical issues are often a cause, especially if you have moving mechanisms that need power, and there's motors connected to those mechanisms, and the motors need power too. So wires can come undone during matches, and that can be a really big common issue throughout competitions. And especially when you have such a limited time between matches, you need to make sure you know what's going to go wrong, you know how to fix it, so you can get the robot back on the field for the next match. You want to have clean wiring, because when a CSA or like robot inspectors come and they look at your robot, you want to see this motor connects here, it's powered here, and you can actually show them where the issue might be and how everything works.
Here's just a couple of the basic tools you'll be using. There's a crimper right there. Basically, you will put a piece of wire inside this little metal thingy, and it'll just be easier to connect up.
Yeah. So yeah. Yeah.
Okay.
So this is one. Oh, did it? Oh, we can't go back. Wonderful. Wait. There we go. Okay, right. So this is a crimper. So if you have a power pole, you can put this in, and then you put your wire in, and you can crimp it, and that allows for much cleaner connections in like a power distribution hub.
This is a wire stripper. It strips and cuts wires so you can just do everything with them. I don't think. Do we have a multimeter in here?
We do have a multimeter in here.
This thing's a multimeter. You can use it to test a bunch of different types of electrical connections, make sure your wiring actually wires. Zip ties, that kind of goes without saying, holds all your wires together and in place. Then, I think that's just a pair of wires.
Yeah, that's just scissors.
Yeah.
But yeah. So wire cutters will probably be the most used tool when you're doing electrical work. Stripping wires, cutting wires, all that stuff. You want gauges 10 to 24. You can probably even go to 12. We don't have massive wires usually, except for like powering the battery or the battery power. And so you'll usually use smaller ish wire cutters. So yeah, you want to use if you never use a wire cutter, you put the wire, you find the gauge of the wire, which should usually be written on the piece of plastic, the coating. You put it in, pull, strip. Very simple.
Yeah, so please do yourself a favor and cut your zip ties after using them. Having those little bit of extra zip tie dangling, it sucks. Just having to stick your hand in there. And don't use flush cutters to be cutting anything bigger than, what does that say, 18 gauge. Then don't use them to cut anything other than zip ties or small wires. Don't cut rivets with them. I don't know who needs to hear that. Do not do that. They will break and have broken. They're also cheap, so buy a bunch. You never know when they'll break.
So when you're wiring a robot, there's going to be a lot of different types of connectors. You're going to have Andersons. You're going to have the Wago. There's others on there that we don't use, and then you can also just solder the wire. Each one has their own advantages and disadvantages. Wagos can be really helpful for when you're first wiring a robot because you can easily open and close them so you can test different connections. That's also really good if you can't figure out why power's getting somewhere. You can isolate a component in a system to make sure that it's getting power and whatnot. Those Anderson connectors, these things, also really great because they're interlockable. You can take wires out of the system, plug wires in a different place. Those are very helpful. Obviously, you have like a more set of permanent connectors, and those are good for holding. Once you're more like what's the word? Like once you know what your robot wiring is going to look like, and obviously soldering is kind of the ultimate. Like you're locking it in place. You are putting a piece of metal in between two wires to make sure it holds together. So that's going to be very strong. But you also don't really want to do that if you're very sure that that's how you want your wiring.
Choosing the
That's what I talked about, isn't it?
that's just the thing you talked
Yeah.
about, so we can probably skip that slide.
Okay. That's what. Variables. That's these things.
Aren't these really powerful?
Oh no, these are the power codes. Those are variables. Okay.
So ferrules, as you can see on the first part, sticking just plain wires into those those small little connectors can get messy and leave them exposed or some strands just sticking out. So if you'll put them into a ferrule first, it makes them so much easier to take out and work with later, and just looks a whole lot cleaner, and you won't be touching any exposed wires. You want to check the correct length for whatever gauge of wire you're looking, then make sure you use a little crimper just to make sure your wire stays in there.
Right. Yeah. So choosing the right connector, we've kind of touched on this already, but you want to have strong and few connectors because the less connectors you have, the less places for failure you have. Yeah, we tend to usually wire directly from our drivetrain motors to the PDH. We try not to have any extra connectors or wires. Sometimes we have to if the wire's not long enough, but we try to stay away from that as much as possible. That way we can have as little points of failure as possible. We also are big fans of soldering. All of our cam wire on the robot this year was soldered. That helped really reduce like failure in the cam wire, as we know it would all stay together. And it was really easy to find a fault because there would just be a wire split instead of just like partially out of a Wago connector. Again, Wagos are really handy for prototyping. You can plug them in for cam wires when you're still figuring out what your robot's going to look like. But you want to have something more solid before you lock down, like as you lock down an idea. We actually used Wagos in 2023, right, for cam?
Yeah.
And we suffered a lot of issues and a lot of device lossage throughout matches because they would randomly come out these Wago connectors mid-match, and then we have to go through a lot of motors just to find where the one wrong connector was. We soldered this year, and we did not have that issue.
Did you have that issue at all with the Anderson connectors?
We've had that issue like once in a blue moon. It does happen. They very do occasionally come out of these, but it's very rare. And yeah, it's really great. We have replacement wire, we have replacement connectors. So if anything goes wrong, you can very easily snip and then get the right gauge, strip. So you can, if you have a wire go wrong, you can have that replacement wire in a tool chest, so you can easily fix it before your next match.
Electrical components are expensive, and they're also all consumable. So you can use
Kit of parts.
you can use a bunch of good part vouchers to restock on all that stuff, but here's just a basic list of a bunch of stuff you might want to get from different stores. So from Automation Direct, you can get zip ties, wire ducts, wire spiral, wrap, and heat shrink. From Clipper, you can get more zip ties, just a whole lot of zip ties. DigiKey, you can get Anderson power poles, SB50 battery connectors, Molexes. From TE Connectivity, you get free samples of Anderson power poles, ferrules, and heat shrink. And then from Rev Robotics, you can get control system components and electrical tools.
Yeah, so here's some best practices for wiring. Obviously, you want to use the right gauge for the right system. You don't want to be using 12 gauge when it's asking for 24 gauge, that's usually not gonna be the best. It's really useful to have color coded, so we already kind of have that. We have power being red, ground, or like power being red, black, and then we have our can being that green and yellow. But if you can color code even further, that's always useful, so you can find which wire goes where, and you don't have to like follow the line all throughout the robot. Zip ties, bundling, wire tracks, like these, and then these like tubes are all really helpful for managing your cables, so there's not just spreads of wire throughout your robot. Having those spreads can lead to like wires getting caught in mechanisms, and that can just ultimately lead to wires being cut, and then your robot not working, which is not good. Yeah, again, you want your wires to be about the right length. You probably want them to be a bit longer than the right length, so that there's a little bit of slack in it. But if you have too much slack, that's going to just lead to excess wire that's just gonna build up and create a bunch of spaghetti in your robot. Again, you don't want like sharp bends, because that can cause, if something gets pulled there, the wire can easily snap, and then something doesn't work. Yeah, and reiterating, wires and moving parts do not like each other. You want to have slack where there's a moving part, but you also want it to be away from the part that could close around it, or anything that could smash the wire.
Here's just a couple good practices for the battery on your robot. Your battery needs a seatbelt because your robot is gonna be moving around a whole bunch during the match, getting hit, running into things, whatever. So it needs a seatbelt, just something to be holding it down so it doesn't fly out and get broken, or just cause your robot to lose connection. Your battery connection shouldn't move, because loose connections equals high resistance. Pulling the battery by the wires can remove the connectors and just generally be horrible for your battery. I've destroyed a battery connector before. It's not fun replacing that. And then you just want to be able to use the most charged battery for your matches to have your robot be as good as it can be.
Thank you. Alright, so if you've ever seen one of these before, the CTR and Red both have these really beautiful system printouts. We have one of these because we use Rev components, or we use Rev Power Distribution Hub. We have one of these printed in the lab. This is probably one of the most important FRC specific, if not the most important FRC specific tool for wiring, because it shows your power distribution hub. It shows all the different wiring for different kinds of motor controllers, motors, how to wire the battery, and then how to wire radio, Robo-Rio, and then everything else that's gonna go to your robot. So it even shows down there, if you have one of these, can be kind of hard to tell, but it even show the gauge of what wire needs to go where. It'll show breakers, and it's a really beautiful chart. It allows you to see a lot of information all in one place. It's a really great quick reference for wiring.
The PDH, or the power supply, is the heart of your robot. Basically every motor, encoder, camera, whatever, will be running through it, and each device will be plugged into it, like I said before, and then each device will also be using a different breaker depending on the manufacturer's instructions and what it's rated for. You want to be checking the wire strip length and connector type for whatever you plug in.
And so the other part of, obviously all the power will go into the PDH. The other part is can wiring. Can wiring is just as important as powering, because it tells the robots, or it tells the motors how to move. Thankfully, it is very different, very distinct. It's that yellow and green. It should run all around your robot in one continuous loop, known as the daisy chain. If one device is not included in the daisy chain, it's not going to work because it won't receive the right signal. It won't know what to do. It'll just know that it has power, and that's not good. It can't be accessed by the code and thus won't run. Each device is going to have its own CAN ID. Each device has to have a different CAN ID from all the other devices, and that's the way of that's how the computer communicates with the motor or sensor or whatever. It has that CAN ID, and it knows that this CAN ID should be doing this kind of things. And that's usually going to be assigned on a Phoenix tuner or a Rev client. That's also really useful. Those clients will let you see which motors you have connected. You can usually like blink them So like literally like have lights blink on the motor so that you can find it on those clients. And then you can also see what motors you might be missing. That way you can run through the daisy chain and see where your faults are, and you can see like what needs to be fixed.
Here's a couple of tips and tricks for reliability. Secure connections are just always good to have. You don't want your robot losing power or having a motor lose connection. Zip tying or just strapping down your main battery will just prevent it from losing power, having any kind of break or malfunction. Wire wrap or heat shrink around your solders will just keep them nice and safe. You want to be checking all your connectors as part of your post and pre-match checklist, making sure that all your motors are connected, everything's connected to power. It just helps your robot not malfunction, and it's the base of most of your malfunctions during the game. Then describing a fix as good enough usually means is not good enough, and you want to be fixing it as soon as possible.
Sometimes you will have to roll with those. We've had matches where we've kind of just thrown something together and said it'll probably hopefully work because we don't have time. But every time that happens, our next priority as soon as the robot rolls back into the pit is fix that good enough to make it solid so we know it won't fail again. And then your robot's going to have issues. That's a fact of life. You want to know how to fix those and how to find those. Multimeters are really great at finding where power is running to and where there isn't power. It can find open circuit voltage drops. It's also, you want to look for symptoms of like wiring issues. So you're going to look for overheating. You can look for current spikes. The driver station hub you can pull up a really big graph. You can see a bunch of different information. You can see the voltage of the battery. You can see current flow. You can see a lot of other information. It also will tell you how your robot might fail. So if you're seeing something that's going wrong, that driver station client is always a great place to look. First, it'll show you, because it can show you a lot of where the faults might be. Again, quick fixes might get you through a match, but you want to have like big changes happen like when you're prepared and once the robot's rolled back and you're ready for them. Here we have some resources for further learning. WPI Lib has a bunch of great stuff when it comes to wiring. It has a bunch of great stuff when it comes to code as well. But the wiring documentation, the first part, has a bunch of stuff on how to wire, good practices for wiring, and all that. And then Citrus Circuits has also put out a bunch of videos on great ways for wiring, running RoboRio, sensors and that kind of stuff. And they're going to have a bunch of solid resources as well. I think, that's all we have. Are there any questions?
Yeah, the picture that you had of all the wiring and everything for the REV and all that, where can we find that?
I believe that's on WPI. I believe they have those in the WPI Lib wiring guide. But if you look up the power distribution overview or FRC control system, any of that stuff, it should be one of the top images because it should be pretty easy to find.
Okay. And the training videos at the end, where do we find those?
If you just look up like Citrus Circuit wiring on YouTube, they have a bunch of great resources. They also have some physical or they printouts, I believe, online for actual wiring walkthrough guides.
Okay, thank you.
Yeah. Any other questions?
What type of solder do you usually use?
I believe we use a mix. It's gonna be it's like lead and zinc, maybe.
Yeah, that sounds about right.
It smells great.
Yes.
It does.
What are schematics and do you use them?
Schematics. I don't.
Like what's on the board right there?
Oh, like the wiring layout.
Do you make a schematic for your robot?
We usually don't. It would be good practice if we did. But having a physical wiring layout can be really helpful of how the wires are all going to interact. It can also be helpful. You need to make sure to if you're making CAD for your robot, you don't need to put in every single wire, but you do need to make sure you have places for the wires to be when you're CADing stuff. Because if you built something that's gonna work perfectly together and there's no space for the wires, it's not really gonna work at all. But yes, schematics can be a really great thing for a robot if you have a guide to what's going to get power from where, and then the different breakers it's going to need, and then where it's going to be located on the robot, that can be really helpful for planning out your robot before you build it.
What about wire labeling?
Oh yeah, just in terms of wire labeling, I believe we had, you can color code wires, that can be really helpful. That's about all we do for wire labeling. We'll color code wires, but that's about it.
Have you talked about keeping your CAN wires away from your power wires?
We've never, that can be an issue if they're right next to each other, but that's usually if they're, if the daisy chain is like an inch and a half away from your power, it's generally going to be fine. I know there can be some weird electromagnetic interference between the two, but as long as they're like not literally touching, they're usually going to be fine.
Crosstalk on an unshielded twisted pair can happen, but like you said, it needs to be pretty close.
Oh yeah. Yeah, oh, thank you. You do always want your daisy chain wrapped. That can, when it's unwrapped, that can cause decently big issues. So it does need to be wrapped. It doesn't need to be wrapped.
Needs to be twisted.
Twisted, that's the one, yeah. It needs to, yes, thank you. Sorry, you know what I'm saying. If the wires are far apart, that can actually cause some pretty decent issues. So you do need them close to each other. Best way to get that is twisted.
Do you guys section your wires into like specific parts? And in case when you guys do, how do you guys usually section them off? For like, you specifically have wires connected to motors or other components of the robot. How do you guys usually take those wires and you put them to the side? How do you usually label it?
Yeah, so that's a good question. Generally we try to have different wires of different types in we have a toolbox that we'll take to competitions, and we also have a bunch of buckets of different gauges of wires. That way, if we ever need a wire of a specific gauge, we can get it out and we can replace a wire or anything like that needs to be done. We also use grommets this year and stuff like this, so we can actually section off the wire inside the robot so that it's going to the different pieces and it's not all just globbed together, so it's easier to find where the wiring issues may be.
What kind of grommets do you use?
We used rubber grommets that went in between holes cut into box tubing.
Okay.
I don't know the specific brand,
Okay,
I
I
just know what
understand
they
what
were.
you
Yeah.
Yeah, a common finger point is a spark plug kind of wire, and there's a very tiny connector at the point. So do you do anything special to prevent that failure?
The CAN wiring for the spark plugs?
Yeah.
Or the spark maxes?
Yeah.
Yeah, that can be, you do want to solder connections where you can. That is a plug-in, if I remember correctly. And you just kind of have to be careful around those. It can help. Taping that stuff with electrical tape can honestly be a pretty decent fix for both short-term and long-term. But anywhere else you want to solder wires.
I mean, that's normally the wire is like a hairs off from the connector. It's like a JSP connector. It's where the wire breaks off from the connector.
Those are the ones that plug in?
Yeah, it's like a very tiny white connector.
Yeah, we've never had any major issues. We've just kind of plugged it in and we've always sat happy with it. Any other questions? Fine. I think that's all we have. Yeah, have a great day.
Thanks, gentlemen. Great presentation.
Yeah,